Managing IT devices can be repetitive and even quite boring, especially if you've got a lot of computers to look after. But they do have to be kept up to date, configurations need to be kept in sync, and you might have to push out the same change to multiple computers and so on. And that is something that Ansible can actually help you with. Now, it doesn't actually need any software installed on any of your actual devices, but you can actually push out multiple changes to computers all in one go by using what Ansible refers to as playbooks. But how do you actually install and use Ansible? Well, if that's something that you're interested in finding out, then stick around and watch this video, because that's what we'll be going over. Ansible involves using a central computer, which is referred to as the control node, which is used to manage all other IT devices on your network. Now, if you're just the only person who's actually going to be using Ansible, well, you could just install it on your own Linux desktop, for instance. But in this video, we're going to be setting up a dedicated computer to run Ansible on. The reason being is I'm thinking ahead in terms of fully automating Ansible. To keep this video as short as possible, I'm going to assume that you've already got a computer which has remote access to all your other IT devices, and that you've got a user account which has sudo rights on those actual computers. And I'm also going to assume that you've got a computer available that you can actually use to set up as your central node. Now, although the goal is to have a central computer which is running Ansible, I'm in a bit of a chicken and egg situation. And that's because, well, even in this lab environment that I've got here, everything is locked down. I've got software firewalls preventing access, as well as a firewall appliance, and I've got user account restrictions in terms of, well, you need an SSH key that's accepted by the actual computers and so on. This management computer, on the other hand, that I've got does have access to everything, and my user account can get access from it. In which case, I'm actually going to start by installing Ansible onto this computer in order to get everything up and running. So the first thing we're going to do is just make sure that everything's up to date on this computer. So I'll do sudo apt update. And that should be up to date. Yep, everything's up to date there. And then what we're going to do is to actually install Ansible itself. So that's just sudo apt install Ansible. And then I've got the -y parameter at the end to basically just save me having to answer the prompt. So hit return, and off it goes and installs all of the software. Now, Ansible uses an inventory file, which provides a list of all the actual devices that you're going to be managing using Ansible. But before I actually create one of those, first thing I'm going to do is to actually create a folder. So I'm going to use make directory, and I'm going to call this Ansible. Switch to that folder. And the reason I'm doing that is it's just to make it easier for me to actually keep track of everything. Next thing I'm going to do is to create my inventory file, and I'm going to use nano for this. But you can call this file whatever you like. It doesn't have to necessarily be inventory. And in fact, you might actually have multiple inventory files for different projects, for example. Then what I'm going to do is to actually paste in details about these computers. Now, I've set this up using IP addressing. You can use fully qualified domain names, you can use host names, whatever's best for you, as long as either the FQDN or the host name, for example, can get actually resolved. But to keep things simple here, I'm just going to stick with IP addressing. The format of this file is what's known as INI or INI, but you can use YAML if you want. And what I've done is to actually set this up with two groups. So I've defined a group called nodes and another group called control. The reason for that is I'm going to have different tasks for these different computers. So I've actually grouped them together based on the actual tasks I want to carry out. So I've got two computers up here, and these are just test computers on my actual network. And then I've got this other computer, which is going to be the actual control node. So we'll save and exit out of that file. And that basically creates my inventory file. Now, Ansible allows you to run what's known as Ad-Hoc Commands. And that's what we're going to do first, because I want to make sure that this computer, and really Ansible, does actually have access to all of those computers we mentioned in our inventory file before we go any further. So I'm just going to copy and paste this command in, and then I'll explain what it does. So we've got the command itself, which is Ansible. Then we've got the -i parameter followed by inventory. So what this does is to actually tell Ansible where our inventory file is. Again, you don't have to actually call that file inventory. That's what I've just called it. But either way, I still have to actually point it to the actual inventory file. I've then got -- private -key, which is to point it to my actual SSH key. The reason being is that all of these computers are locked down but only allow access using SSH key authentication. I've then got the all parameter, which is to tell it to target all of the actual devices in the inventory file that we're pointing it to. Then we've got the -m parameter, which is to tell it what module to actually use. And there are a lot of modules in Ansible. In this case, we're using the ping module. So when I hit return, it doesn't actually just go off and ping the computers as such. It does actually check to make sure it can actually log in. So in this case, it's gone through all 3 of those computers and it's come back. Everything is in green and it's been able to actually connect to those. Now, if you're the only person who's going to be using Ansible, then you could just run it with your own user account. But when you've got lots of users, or in my case, I want to set up full automation, then you really need a dedicated user account for Ansible. Because we want to use SSH key authentication, and I'm going to have to create some SSH keys for it as well. So first thing I'm going to do though is to create a folder. I'm going to call this files, and the reason being is that we're going to tell Ansible about these files and it's going to look for them in a folder called files. I'm then going to switch to that actual folder and then we're going to run the SSH keygen command so that we can actually create our key pair. So I've used the -t parameter and specified 825519 because I want to use that algorithm rather than the default of RSA. I also want to give the actual keys a name of Ansible-key, so I've used the -f parameter. I also want to put in a comment, in this case the user's actual email address, so I've used the -c parameter. That makes it easier to keep track of keys. Now, I would suggest using something less obvious than Ansible. It's just blatantly obvious as to what this is for. So do use something different, but for the sake of this video, I'm just going to keep it simple. But I'll hit return. Now, it asks for a passphrase, and normally it would be a case of you would put something in here. If somebody gets access to this key, if you've got a passphrase on it, they would have to know what the passphrase is to be able to use it. The only trouble is that's going to cause a problem for automation. I mean, yes, we could actually log in as the user and we could actually cache the actual passphrase while the key is getting used. The only trouble is that causes a bit of a problem if you want really full automation, because you want the computer to be able to auto recover. And I don't want to be in a situation where I've got an actual task getting run 2 o'clock in the morning every day, 365 days for the year, and well, it doesn't work because it needs somebody to put the passphrase in which case we're going to really bend the rules here when it comes to security. I'm just going to hit return and then return again so that this actual key doesn't have any passphrase at all. If we have a look at the folder, we've got a private key here and we've got a public key, but you really need to be careful with this key. You've got to really restrict access to when it comes to who can get access to that actual key, specifically because later down the line you're going to find that we'll be using this key not just to be able to log into computers, but it'll have full rights to be able to do whatever it likes on those computers as well. So normally you would have a passphrase on. In this case, there is none, so you've got to be all the more careful about protecting that key. So we're talking about putting it on a computer that sits behind a dedicated firewall. Access to that computer is then restricted through the firewall. When it comes to user authentication of that computer, that has to be strongly locked down as well. We're even talking about encryption of the hard drive. That way, if somebody manages to actually steal a hard drive, and the same applies even if it's a virtual machine, somebody needs to know what the actual encryption password is to be able to get a hold of that key. Because once somebody's got that key who shouldn't have access to it, it's going to be pretty much game over. I mean, we will have access and restrictions in terms of which computers can get access to the other computers, but security is all about layers basically, and we've got to be as safe as we possibly can. So you really, really want to lock down that key as to who's got access to it. So I'm just going to switch back to the main Ansible folder. Now what we want Ansible to do is to actually make changes to computers. So we're talking about installing or removing software, adding, removing files, changing files, and so on. And to do that, it needs root access. Now, it can use different methods, but I've got a mixture of Debian computers and Ubuntu computers. So by default, Debian doesn't have sudo installed. Ubuntu computers, on the other hand, don't ask for a root password when you actually install the operating system. Although, to be honest, it's not a good idea to log in as root anyway. In which case, going forward, the best strategy that I can see is to make sure that all of the computers I've got the actual sudo package installed. To do that, we're going to run a playbook using Ansible. So I'm going to create a file using nano. I'm going to call that install_sudo.yml because this is going to be a YAML file. That's what Ansible uses. Hit return. And then I'm going to paste in what is basically a play. So we've got a playbook, and the playbook can consist of multiple plays. In this case, we just got one because our purpose is to install sudo, and that's it. So right at the top here, we've got hosts and then nodes. So what I'm telling it to do is to actually target the group of computers called nodes. And then I've got become set to true, which is to actually tell Ansible that we wanted to switch over to the root user account because by default it doesn't. We've then got this section here, which defines the tasks for this play. You can have multiple tasks, but I've only created one, so that's this one here. And I've given it a name, and that is install sudo package. The idea is that when I see the actual output, as this task runs, I'll be able to see that name, so it makes it easier to interpret everything. So for this task, we want to use the apt module, because that's what Debian and Ubuntu use. Then we've got a name, followed by sudo, because we wanted to install the sudo package. I've then got update cache set to yes, so that's basically apt update. We want to get it to update the repository information. And it is optional, but I've got this cache underscore valid underscore time, which is set at 3600, which basically says update the cache, but only if it hasn't been updated within the last hour. So this is useful to basically keep the load off the actual network. And it makes a lot more sense when you're running this for a lot of computers and you're running it quite frequently, but it is optional, but it is quite useful, I find. And then finally, we've got the state option, and I've set this to latest. Now, by default, this is set to present. When it's set to present, what that means is when it runs the task against the computers, if sudo isn't installed, it would install the software. If it's already installed, it just leaves it alone. By setting it to latest, I'm actually telling it to also update existing copies of sudo. Hence the reason why I'm also running the update cache. It's not just applying this for computers that don't have sudo installed. It also applies to computers that have it installed, but the actual package is out of date. So that's our play. So I'm going to save this file. And then what I'm going to do is to actually run the command to run that playbook. So instead of using the Ansible command, which is just the Ad-Hoc command, we're actually running Ansible-playbook. Then we point it to our file, which is the playbook install_sudo.yml. As before, I've got to tell it where the inventory is with a -i parameter, where my private key is using the --private key parameter. Now, by default, Ansible is going to try to use sudo to actually switch over to root. And, well, that's not going to work for a Debian computer because, well, it doesn't have sudo installed. So I have to change the become method here to su or switch user. And I have to actually give it the actual password. So at the end, I've got a -k parameter. So that will actually prompt me for the actual root password. So it wants to know what the root password is. So I'll put that in, and then off it goes. So first thing it's doing is it's running this play. Then it's got task and it's gathering facts. First thing you'll notice is it's failed against this computer. The reason being is that this one is actually an Ubuntu computer. So the root password won't work for that one. It's then actually run my task. Now, it only applies to this computer, 192.168.101.10, because it couldn't log into it in the first place. But you can see it's referencing this as a change. We've got our task name. Like I said, it makes it easy, but it's telling us that by running this task, something has changed. And then lower down, it gives you the summary information, or what it calls the player recap. So when something changes, it's in yellow. When something fails, it's in red. When something succeeds, it's in green. So for this computer, which is a Debian computer, we've got two things that were okay, one thing that was changed. So that's changed there. Whereas with the Ubuntu computer, it just failed flat out. But what it means is now I should have two computers, one with Debian, one with Ubuntu, and both have got Sudo installed. So going forward, what I'll do is run this command if I want to use this playbook. So this time I don't change the SU, the actual become method to switch user. I'll just use the default of sudo. So otherwise it's the same. So if I run that, put in the password. Now this, on the other hand, what it's doing is it's using my actual user account. Essentially, it's using my key, and it's also using my user account and my user password to actually get root access through sudo. So this time round, it's asking for my user account password. So I'll hit return. Off it goes. So it's succeeded against both of them in gathering the facts. We'll see how it goes in terms of sudo. So it's taking a bit longer on the other one. So it's quite possible that that one needed to be updated. So yeah, it just took a while. With this particular computer, it's now saying this has changed. In other words, it actually has to go out to the internet, run a complete update of the actual repository in this case. So it took a while to do that, get all the information. But once it did that, it's then actually carried out the change and updated sudo on that specific computer. So that's why that one took a bit longer than the other one. But essentially now, I can just keep using sudo going forward. I mean, I can run it again, and this time it should go quicker because there's no need to update the cache at all. So quickly gather the actual facts again. Yeah, so there you go. Didn't need to update the actual repository information, didn't need to make any changes. So this time the tasks carried out much quicker. And that's something to point out about Ansible, is the fact that you ask it to do something in a task, but it only actually carries out changes if those changes are necessary. That's one of the really useful things about Ansible. I mean, this took a long time to sort out, whereas the next time I ran it, there was nothing to do, so it was really quick. So that does give Ansible a really big benefit compared to other automation tools. Now our goal is to have a centralized computer, a control node, which can log into other computers and make changes to them. And even with just two computers, it does need quite a few changes being made. In which case, easiest thing to do is to, well, use Ansible on our management computer to set this all up. So what I'm going to do is to create a new playbook. I'm just going to call it Ansible_bootstrap.yml. Then I'm going to paste in multiple players to this actual playbook, because you've got a playbook, and within the actual playbook you can have multiple players. The first one, which is this one here, is to create a new user account on all of our computers for Ansible. So I'm going to target all of the actual computers that we've got in our inventory. We need to switch to root, so we've got become set to true. Then we've got our tasks section, and I've only got one task, and that's to create the actual user account. So I've given it a name of create user Ansible, and then we're going to use the user module to create that user account. I've given it a name of Ansible, but it would make sense to actually use something less obvious. And I'm also telling it to set the shell for this user to be /bin/bash. Now, I've got this surrounded by single quotes because the value needs to be a string. As you'll see lower down, I've got some other settings where I've actually got double quotes. So it is quite flexible. It's up to you as to what you want to use. But the reason I do that is just to make the experience easier when I'm logged in as Ansible. If I don't, well, you don't really get any feedback from the prompt. You just get a $sign. So you don't know who you're logged in as, you don't know what folder you're in, you don't get auto completion, you don't get task history and so on. So it's best to put in some shell, and bin/bash tends to be the usual one you use. One thing to point out is there is no password assigned to this user, and that is deliberate. If you don't have a password, you can't actually log in as that user. This is going to be a central computer that everybody's going to be using, and I don't really want people getting access to a password. I want to control all this through SSH keys, so that's the reason I'm not setting a password. Then next what we've got is another play, which is here. Now in this case we're targeting what I've called nodes. That's the group in the inventory called nodes, so all of my test servers. Now what this is going to do is to run two tasks. The first one is to upload the public key that we created for our Ansible user. So I'm using the authorized key module, and I'm telling it that this is for the user, Ansible, and then I'm telling it what the actual public key is for that user. By doing this, it's going to allow our Ansible computer to actually log in to the other computers using SSH key authentication. And then I've got another task, which is to give the Ansible user sudo rights. There are different ways you can actually do that, but what we're going to do is to copy a file, and the file is going to be called sudo_ansible, and it's going to copy it to a destination of /etc/sudo_d, and it's going to call the file Ansible. We're going to set the ownership to root, and we're going to change the actual permissions as well. Now, by doing it this way, it's a bit easier to actually control who's got sudo rights. All I need to do is, if I want to revoke the right, is just delete that file in the folder, and that's it. The user doesn't have sudo rights anymore. But what you can also do is within the file, as you'll see shortly, you can actually set what permissions, or what commands rather, the actual user can use with sudo rights. Then what we've got is our other play, which is targeting the actual control node itself. Again, we need root access. First thing we're going to do is we're going to upload my own SSH public key, but it's going to go into the Ansible user account. The reason being is that, well, we're going to have multiple users actually logging into this computer, but they're all going to be logging in as the Ansible user, and I'll be controlling who has access to the computer through SSH keys. So the idea is that if somebody wants to be able to control Ansible, they'll need authentication through SSH keys. Those keys will hopefully have strong, complicated passwords on them, making it difficult to get access to the actual computer if you don't know what the passphrase is, at least. But it also makes it easier to then revoke rights. So by doing it this way, nobody can actually log in with a username and password. They have to use an actual key to be able to get access to the computer, to then be able to use Ansible to make changes and so on. And then what we're going to do is to upload the public and private keys. Obviously we need the private key because the computer needs to get authentication using SSH keys to the computers that it wants to log into. So we've got to have the private key uploaded. We're using the copy module to do that. We're telling it the source of that actual file, which we all created all these earlier on. So the private key is Ansible-key, and we set the actual destination to the .ssh folder for that user in their home directory. So it's /home/ansible.ssh/ and then I'm just going to keep the key name the same. But I do have to change the ownership, and I do have to change the actual permissions. It certainly doesn't like it if you've got this setup where the group or other has even read access to an actual private key. So we're restricting this that only the owner has write access. I'm uploading the public key because, well, part of the the work that I want Ansible to do is to just keep everything in check. So it'll be doing things like checking to make sure that there's public keys are on all of the actual computers, including its own. So I'm uploading that same method as before, just using the copy command. So we'll save our playbook here. And then because I mentioned a file, what I'm going to do is create that file. So this goes in the files folder. So I'm using nano to create the actual file. And as I mentioned in the playbook, it's going to be called sudo_Ansible. You can use whatever name you like though, but it's going in this files folder because that's where Ansible is going to look, because we didn't specifically tell it where the file was. So that's where it's going to be looking. And what this file needs to know is, well, basically what we're setting here, because at this stage I don't know what commands Ansible really needs access to. So when it comes to the actual rights, what Ansible can do with sudo rights, I'm just setting it to all. So it's got all rights. It can run any command essentially there. And then what I'm also doing is I'm actually setting it so that there is no password prompt when it switches over to sudo. Again, this is all to do with the full automation. I don't want to be in a situation where it breaks, basically the computer needs a reboot or something, and then nobody notices for quite a while that Ansible hasn't been running, for instance. I want it auto recovery so that when I've got automated tasks, the whole system will auto recover. So again, this is why I'm going to be very, very careful with this Ansible user account. We're giving it root access at this stage to everything. There's no passwords. So what we're going to be doing though is to control access to the computer through those SSH keys, which at least they have passphrases on them. Anyway, we've created our file. This is the one we're going to upload, so I'll just save that. And the next thing to do is to actually run this playbook so that it carries out all this work. So we'll be using the Ansible playbook command. We'll point it to our playbook, tell it where to find the inventory with a -i parameter, tell it where to find our private key with the --private -key parameter, and then we use the -k parameter so that it prompts us for our actual password for sudo. So it's asking for my password now, and then off it should go. So because it's the first time I'm using it, the computer wants to know as well what my private key password is, and I think I can't type. Nope, still doesn't like it. There we go. So it's just going to go through a process of gathering the facts, and then it's going to start running through all of those plays in order, including all of the actual tasks. So it's already created the user on the 3 computers. It's uploaded the SSH key. It's uploaded our file to get sudo rights for Ansible. And then in the next and final play, you can see it gathered facts for that one. That's something to bear in mind, is every time you're actually running a play, it'll be gathering facts. You can, if you want, disable these sort of things, but in this case I didn't do that. I've just left everything at its defaults. But it's gone through all of these plays, and you can see it's made quite a lot of changes, and it hasn't come back with any problems. So at this point we should be at a stage where we've now got a central computer where we can actually log into it, and then we can actually start setting Ansible up on that to actually basically manage all of our computers. Now, the one thing which is missing from our actual control node is Ansible itself. Now, I could actually log into that computer using SSH and then go through the normal install process, but since this video is all about Ansible, then we'll use Ansible to install it. So we'll create a new playbook, and I'll just use nano for this as usual, and then we'll call this install_ansible.yml. I'll then copy and paste in the play to install the package. So we only want to target the actual control node itself to install the software. We do want to switch to root. Then for our task section, we've just got one task, which I've called install Ansible package. We're going to use the app module because this particular computer is running Debian, and I need to tell it what the package name is. So in this case, it's Ansible. I do want the repository information updated, so we've got update cache set to yes. And I only want this done if it hasn't been updated within the last hour. So I've set cache_valid_time to 3600. Now, although this computer actually doesn't have Ansible already installed, just out of habit I'm setting the state to latest rather than the default of present. But we'll save that file, and then we'll then run the playbook to get it to install Ansible. So Ansible-playbook is the command, pointing it to our file, install_ansible.yml, pointing it to the inventory file using the -i parameter, pointing it to my SSH key using the --private-key parameter, and telling it that we want to be prompted for our actual password using the -k parameter. So it wants our password. I'll put that in. So it goes, gathers some facts, and then it'll start the install process. So it's probably going to take a bit of a while here because by the looks of it, it needs the actual repository information updated. So that's what it's actually going through. I mean, you could set that up as a completely different task to do that. But in this case, we've included it as actually part of the actual task just to install the actual software. So it's taking a bit of time to actually do this. Now, as you can see, Ansible has actually been installed because when it comes to the actual tasks, it says it's changed. We don't have any failures, anything skipped or anything, so the actual installation was actually successful. I mean, obviously Ansible wasn't already installed in it, so it's had to download not just Ansible itself, but quite a lot of dependencies that go with it. But it has completed that, which means that Ansible is now actually installed and almost ready to use. And although I'm using a lab for this video, all of the computers that I've got are sitting behind an actual firewall appliance to restrict access to them. So I've had to update the rules on that firewall to allow SSH access from this control node that we're creating. But the computers themselves also are using UFW, uncomplicated firewall, to restrict access. So I do need to update these test servers that I've got to allow the Ansible computer to get SSH access to them. So we're going to use Ansible on this management computer to set that access up. So I'm going to create a file called firewall.yml. Then I'm going to paste in my play to update UFW on my computers. So we're going to target the nodes groups, that's the 2 test servers. We do need root access to make these changes. There is only one task, and I've just called that allow SSH access because that's what we're going to be doing. I'm using the UFW module because it's UFW installed on those computers, and that's what I want to change. The actual rule itself that we're creating, I'm going to use the limit option because that makes a lot of sense when you're using something like SSH, because I want to limit the number of attempts that somebody is allowed before they actually get locked out from connecting. So it's a useful feature to have, whereas if I just set it to allow, then you've got the risk of brute force attacks basically. By setting it to limit, at least I'm slowing it down a bit. For the protocol, we want to use TCP because that's what SSH uses. And then I'm going to set the actual source IP address in that rule, which is for my control node, which in my case in this lab, it's 192.168.200.15. It's got to be a string, so I've put it in quotes. And then we've got to set the destination port, which is 22 for SSH. So we'll save those changes. I mean, one thing to point out is because I'm using virtual machines, there's no actual dedicated management interface on them. If I want management access, I could always just get access through the hypervisor anyway. So that's the reason I haven't actually specified a destination IP address. But in any case, what we want to do is to then run this playbook and get it to update our computers to allow access. So we'll run Ansible-playbook, point it to our firewall.yml file. I've got to point it to where the inventory file is, where my actual personal private key is, because we're logging in as ourselves. And I've also got to get it to prompt me for my password. So I'll put in the password, and then off it should go and talk to those 2 computers. It's gathering the facts, and now it's, well, pretty quickly it's updated UFW. So it made 2 changes. So it had to add some additional rules. And that's basically it. We should now be able to get access to those computers from our control node. Now the next thing to do is to actually log into our control node and test that Ansible's working. Now we want to log in as the Ansible user, but we want to use our own actual SSH key. This way we can control access to the actual account using SSH key authentication. There is no password, meaning you can't just log in with a username and password. You do need keys. And I've got the flexibility to then be able to revoke access just by removing someone's public key from the computer. So to make my life easier, what I've done is my config file for SSH looks something like this, basically. Right at the top here, I want all hosts to be using identity keys only. And whenever the computer sees me trying to connect to a computer called Ansible, it's going to interpret that as having a host name of, and then I put the FQDN in for the actual computer, and I'm pointing it to my own actual SSH key. So that's just going to make my life easier to log into this computer, because I don't still need to tell it that I want to log in as Ansible, but I just put in SSH Ansible at Ansible, hit return, and that's it. It's logged me in. It didn't prompt me for my passphrase for my actual private key because I've already done that. So I've got straight into the computer. Now, when it comes to managing Ansible, it's entirely up to you. You might have different circumstances as what you're going to use Ansible for. Maybe you've got projects, for example. In my case, what I'm going to do is I'm going to have a folder called live, and I'm going to have another folder called test. The reason being is that even though this is a lab, I still need to maintain the lab itself. So I'm going to have a folder for that called live. And then when I want to do tests with Ansible, I'm going to do those within this test folder. So because this is a video demo that we're doing, I'm going to switch over to the test folder and we'll do our work from there. Now, Ansible's only just been installed on this computer, so I need to tell it about the computers that we want Ansible to get access to. So I need an inventory file. It's going to be the same 2 computers that we were using before, but this time I'm going to split them up just so I can do some demonstrations of different things you can do. So the first one, I'm just putting that into a group called NTP servers, and the second one, I'm putting that into a group called name servers. But the reason I'm doing that is because most of the stuff that I've got is just infrastructure servers. Maybe you've got database servers, file servers, and so on, and you'd normally group computers based on functionality and what their actual purposes is. But in my case, I'm just doing this as a test, and I do want 2 computers, so I'm just basically making these up just so I can split them in 2. But we'll save that inventory file. Now, one thing I'm going to do is to create a file called Ansible.cfg. This way we can change some of the default behavior of Ansible, and it'll look for that file in your working directory or elsewhere. So as long as there's a file called Ansible.cfg in your working directory, that takes precedence over other ones. The reason I want to do that is I want to paste this in. So I'm setting the defaults, and I've got to change the host underscore key underscore checking value to false. The reason I'm doing that is because whenever you log into a computer the first time, you usually get prompted to actually confirm the fingerprint and so on. And I don't want to do that. If you've got hundreds or thousands of computers, that's going to be a real pain. So I just want to disable that. And then what we're going to do is just run the ping command, or module I should say, using an ad hoc command. So running Ansible, pointing it to our inventory file, pointing it to the private key. So in this case, it's the actual private key for Ansible itself. I want to target all computers. So that's the 2 test computers mentioned in the inventory file. And the module that I want to use is ping. Again, it doesn't just ping them, it actually logs in. So this is going to check to make sure that it can actually connect into those 2 computers. So we'll hit return. And remember, there is no actual passphrase on the key, so we don't need any prompts. So it's come back and said, yep, the results are a success. Everything's in green, it didn't have any problems. So at least I know that this computer can get access to the 2 servers. but I'm going to make another change to that config file just to make my life even easier. And I'm going to add in 2 more lines. So that's these 2 here. I'm setting the inventory to be inventory. In other words, I'm telling it that by default, just use the inventory file unless I tell you otherwise. Same with the private key file. Unless I actually specify a different key in the command, it's going to be pointed to and use the actual key for our Ansible user. So I'll save those changes. The reason I want to do that is because now I can do the same thing with that command. All I have to do now is just tell it what I want to target, point it to the module. I don't have to point it to my inventory file or my private key anymore. So I'll run that again. And there we go. So it's done exactly the same thing as before, where it's connected into those actual computers. But this just makes the whole process a lot easier. Now, up to now, the way that we've been using Ansible is that whenever we want a change made, we create a playbook and then we run it. And you can certainly keep doing that if you want, but when it comes to actually maintaining all of the actual devices on your IT network, the steer is towards having a single playbook. So we're going to create a one, and we're going to call this one site.yml. Same name as in the Ansible example, but I'm going to keep that because to me it does actually make sense. It's to look after all the devices on the site. And then I'll copy and paste some players. So the idea behind this playbook is that you'll have a player to target all computers. They'll all need certain software and certain configurations on by default, so you'll do that within the first player. After that, you'd start setting up players for certain groups of computers. You'll have one for your database servers, one for your file servers, and so on. Each of those groups needs certain software, certain configurations, and so on. In this case, I'm just really focusing on just a few things. It certainly doesn't cover everything I need to do because I want to keep things as simple as possible. So we start with a first player which targets all computers, switches to root, and then we have what's called a pre-tasks section. Up to now we've just had a tasks section, but the pre-tasks one is when you want things done before anything else. There's also a post-task section you can put at the end of a player, typically for cleanup jobs. In this case, what we want is to update the repository cache on all of our computers. So because they're Debian and Ubuntu computers, we're using the app module to do that. And all we're going to do is update the cache as long as it hasn't been updated within the last 1 hour. Now, part of the reason for wanting to do this is basically because I just want it as a one-off task. There's going to be a lot of other things to install, update, when it comes to an actual site playbook, and there's only really any point in doing that once. You don't want to do it every single time you're checking to see if any software needs updating. So we're doing that right at the start of the playbook in this first actual player that targets everything. I then have another section which is called rules. So the reasoning behind that is that if we used a task section, we'd end up with a really, really long actual playbook, and it would get very, very difficult to maintain it. What Ansible gives you is a way to basically split out all of your tasks into rules, which I'll go into more detail later on. But what I'm doing here is to call on a default firewall rule. This one is going to be to set up the default firewall settings for all of our computers. And then just like with the tasks, you just keep adding more to the list basically. The benefit of doing that is, well, you certainly don't end up with a really long playbook, which would be very, very difficult to maintain. We'd end up with individual rules that we just have to manage and update every now and again, which not only makes it easier for maintaining all of this, but it also allows us to actually set up these rules and have them portable so you can actually use them among other playbooks if you want. So it's a really good feature to have. In any case, all of these computers do actually need cronny installing. The only trouble is, well, although we'd install the same software, the problem is an NTP server and a client has a different configuration. The config file is the same, but the contents are different. And that poses a bit of a challenge because, yes, I want the same package installing, but I want a different configuration file depending on whether it's a server or a client. So what I've now done is to actually split this into two actual plays. They both call the same rule, which I've called cronny, but they do different things. They're going to tell essentially that rule to either target an actual server or a client. So what we've got is our first play here, which targets the clients. It's easier for me to actually pick out the servers because I've actually got a group called NTP servers, but it's a bit complicated when you think about it all. How do I define what the actual clients are in that case? The easiest way I could think of was to, well, exclude the actual NTP servers, because what you can do in Ansible is when it comes to the targeting, I can target all computers, excluding, so the actual colon followed by the exclamation or bang means to exclude. I'm targeting all computers excluding the NTP servers, so that basically means the actual NTP clients. I've then got a setting gather facts set to false. The reason being is, well, by default it's set to true. Well, I've already done that as part of the first play, so there's no point repeating it. So for every other play that we'll have in this playbook, we'll be setting gather facts to false. And then in our rules section, this is slightly different to the rules section here because I want to pass a variable across to our actual rule. So what I've got to do is target the actual rule itself with this rule colon and then the name of the rule. And then what follows that is the variables that I want to pass across. In this case, I just want to pass on one. So this plays for clients, in which case I've got a server variable set to false. In the next actual play where we're targeting NTP servers, I've got the same gather facts set to false. I've got the same rules section and we're telling it to use the cronny rule, but for that variable, I'm setting it to true. So when Ansible goes through these cronny rule, when it runs it in this play, server's going to be set to false, but when it runs it in this play, server's going to be set to true. So it's going to behave differently depending on what that variable is, as I'll show you later on when we get into rules. But that's just a bare bones playbook that we've got set up for our site. So we're going to save this, and that at least gets it started. Now, when it comes to setting up rules for Ansible, it's not just about creating a file that contains a list of tasks. You actually have to set up an entire infrastructure of folders for rules, which looks like this. And we need to start setting up some folders for our two rules. So I'm just going to copy and paste a command. So we're using makedir to set up a folder called rules. Within there, we're going to have another folder called default_firewall and another one called cronny. And then within each of these folders, we're going to have another folder called tasks. Because none of these subfolders and even the rules folder itself exists, we're going to use -p so that we can get all of these subfolders created all in one go. Next thing we're going to do is to define our actual role for the default firewall settings. So I'm going to create a file called main.yml because that's what it has to be called. And that's going in the roles /default_firewall/tasks folder. Then I'm going to copy and paste in tasks that we wanted to do. First thing is to install UFW. So we call it apt and tell it that the name of the package is UFW and you want the state to be latest. In other words, if UFW isn't installed, install it. If it's already installed, then if it's out of date, update it. We then need to allow SSH access or make sure it is allowed. So we call on the UFW module here. And then for rule, we're set it to limit. That way we can at least try and slow down brute force attacks. The protocol for SSH is TCP and its destination or to port is 22. Now, rather than having multiple tasks for every single computer or subnet that needs access, I'm using a loop option here. So for the from IP, I've got the opening curly brackets, two of them, followed by item, and then we close the curly brackets. And what that's going to do, it's going to reference items in this list. So what I can do is just maintain the list of IP addresses or subnets that need SSH access. So I've got one task essentially doing the whole thing. So as I said, to me this seems a bit easier and cleaner for maintaining multiple actual devices that need access going forward. And then finally what we've got is we're going to make sure that UFW is enabled. So we call on UFW and we make sure the state is set to enabled. Now the thing to bear in mind is I'm doing that at the end here because my concern is that if we install UFW for the first time and then you enable it, the problem you can run into is that if you don't have any rules already defined, you can actually get locked out. So that's why I'm going to do that right at the end there. So we'll save the changes there, and then we'll set up our role for cronny. So this time we're going into roles/cronny/tasks, but again, the file's still main.yml. Then I'll copy and paste in these tasks. So the first one is to install cronny. So we call on apt, we tell it the name of the package is cronny, and we tell it we want the latest version. So again, if cronny isn't installed, install it. If it is, but it's not up to date, make sure to install the latest version. Now, this is where I'd say things start to get interesting because, well, I need a different config file for clients as opposed to servers. The actual file itself is the same, it's just the contents. So what we're going to do for clients is to call on the template module, and I'm pointing it to a file called cronny_client.conf.j2. It's a Ginger2 file that Ansible uses for this. So that's the source file. The destination is going to be /etc/cronny/cronny.conf. I need to set the ownership and the permissions. Now, I only want client computers to have this specific config file. So I've got a when option here, and the condition is if the server variable that gets passed through is false, then we'll run this actual task. And then finally, I've got a notify option to run what's known as a handler called restart_cronny, which I'll explain later. But basically, this is because if you change the config file for cronny, you've got to restart the service, and that's what this is going to do. But we only want to do it if the actual file is changed. We've then got a similar task, except it's the actual server. So this does pretty much the same thing, except it's going to call on a different file as the source, cronny_server.conf.j2. Goes to the same destination, same ownership, same permissions, but this only gets run if the server variable is set to true. And again, we still need to restart cronny if that file changes. The last thing I'd need to do is to set up the NTP server firewall. So we're going to call on UFW. For this rule, we're going to use the allow option. Protocol is UDP. The to port or destination port is 123. Now, in this case, I might need multiple rules for all the different subnets that are going to need access to my NTP servers, in which case I'm actually setting up another loop here. So as before, we've got our opening curly brackets, then item followed by some closing curly brackets. What differs about this loop though is I'm actually using a variable. This is an external variable, which I'll explain later. But what this allows me to do is to actually define the subnets that are going to need access to my NTP server in a separate file. That way I just need to basically keep the actual variables file up to date. I don't have to keep coming back into this actual list of tasks here. But because this only applies to NTP servers, I've got a when option here to say, well, only use this task if server set to true. So we'll save that. And that actually gets our tasks defined for our roles. Now, one thing that we need to do for our cronny role is to upload a configuration file to our servers. And although Ansible does have a copy module for that, I want to actually use templates instead because you can define variables within a template file. So first thing I need to do is to actually create a folder for our templates. Not surprisingly, it's called templates. And then I'm going to create the actual template file for our server. So the task was referencing that as cronny_server.conf.j2. I'm just using J2 as the extension because this is for Ginger2. Then I'll copy and paste in the contents for this configuration. Now, it's just your basic default configuration you'd expect to see for cronny, except I've removed some settings which allow NTP servers to be learned through DHCP as well as through files that are uploaded to a specific folder, because I want to control all of this through Ansible. And what I'm defining is what actual server that I want Chrony to connect to. So we've got our server option here with iburst at the end, but rather than having an IP address in between there, I'm actually using a variable instead. Then right at the end, what I've got is the allow statements, because by default, Chrony doesn't allow access to the NTP server. Now, again, I want to be able to control which subnets have access to the NTP server using variables. So the actual variable that I'm going to be using is going to be called subnets. And that point is, well, there could actually be more than one subnet. You've got to have an allow statement for each of the actual subnets that you're going to provide access for, in which case I've actually created a for loop. So this is the beginning of the for loop, this is the end of the for loop, and then what we've got in between is the actual allow line that we're going to be using. Now, within a for loop, I'm using subnet as the reference for the item in the list. In other words, we'll start with the first subnet, we'll then put in a line allow followed by what that actual subnet is. If there's more than one subnet, we'll add more lines, and it just keeps repeating, works its way through those actual subnets in the list. Now, I've just called this subnet. I could have called it something completely different. As long as these two items here are the same, then that's fine. But that is the variable, the external variable that we'll be defining later. So I'll save this. And the benefit of this is that I'll be able to basically leave this file alone now and start declaring everything within the variables. If something changes, I just need to update the variables, not the actual main configuration file. To me, it's a bit more efficient, but it's also going to be making it a lot more portable as well. So we've defined a file for our servers. Now I need to create one for the clients. So this one's just chrony_client.conf.j2. And I'll copy and paste this one in. So this is basically the same, except this time the line for our server is going to be our internal server. So what I've got is a variable called internal server for this one. We don't need allow statements for this one because it's for the clients. So I'll save that file, and that gives us our templates. Now, because we've been using variables within our Chrony rule, we're now going to have to actually define what they are. And the first thing I need to do is to actually create a folder. So this actual folder is going to be called vars. And then what I need to do is to create an actual file to store our variables in, and that file is called main.yml. Then I'm going to copy and paste in the actual variables that we've been using. So at the top, I've got one called external_server, and I've given that a value of time.cloudflare.com. So that's what our server, our NTP server, is going to be pointing to. So this is an FQDN, because Chrony can use IP addresses, FQDNs as well if you want to. So in this case, when it comes to the actual internal server, in other words, the server that the actual client's pointing to, as you can see, I'm using an IP address instead. Now, I've also got a variable called subnets, which is, as you can see, a list of the actual subnets that I want to allow access to the NTP server. Now, this actually gets used for the UFW rules as well as for actual Chrony configuration. So what we've got is two separate lines here, but basically this variable is a list of subnets. So I'm going to save that file. But the benefit that I see of doing things this way is that I've got one file now that I just need to update going forward if an IP address of a server changes, or I need to add more subnets to give more subnets access, or make changes to remove access and so on. It should be a lot easier to maintain that main.yml file than having to go through different actual task files and so on. It's also going to be a lot easier to port this across to another environment, because the config file is pretty much the same. It just comes down to, well, what NTP server do you want to point to, and what subnets do you want to allow access to. So for me, yes, it takes a lot more work to set this up, but in the longer term, it should be easier to maintain and port between different environments. But now we've got our variables declared. Now cronny uses a configuration file to store its settings in, and if the contents change, we need to actually restart the cronny service. Now you can actually have a task to restart a service, but you always run the risk that either a service gets restarted multiple times or not at all. So the more efficient way is to use what's known as a handler. All it needs is one actual task to notify the handler and it'll get restarted, but it'll only get restarted once. So when it comes to handlers, we need to create a folder which is called handlers. Then we need to create a file. Hopefully you're spotting the theme here. It's called main.yml. Now you would store all of your handlers in here, but we only need the one for the cronny service. So this one's got a name of restart_cronny, so that matches up what we're referencing with notify in our task. Then we're using the service module, telling it the name of the service, in this case cronny, and telling it that we want a state of restarted. In other words, we actually want it to restart the service. So we shall save this file, and that gives us our handler. So now that everything's been configured, next thing to do is to actually test out our playbook. So we're going to run this command, Ansible-playbook site.yml, hit return, and then off it goes. So our first play, which is for all nodes, and we're gathering facts, updating our repository cache, making sure that UFW is installed, allowing access for management, enabling UFW. Then we get to our clients and, well, it's fallen over. Now, the clue really should be in the error, and I must admit, this is really doing my head in for a while trying to figure out. It's like, I've run into these sort of problems before because it's an Ubuntu computer that I'm trying to update, and I'm thinking, well, we haven't had any problems with UFW. Why is it? I mean, it must have sudo rights and so on. And it was seriously like, I'm thinking, well, why is it not working? Yeah, it's a rookie mistake, basically. The clue is in the error. Are you root? Yeah, Ansible does have, rights. It's a member of the sudo group. I gave it permissions to run basically everything with sudo rights. The only problem, maybe you might have spotted this, is I kind of dropped the ball on the actual playbook. I didn't actually set the actual play up properly to tell this to become root. So that's why. So when it runs these plays, it's not actually switching over to the actual root account, and that's why it's not working. So we'll put that in. Hopefully that should fix it. So I'll save that. Run our play again. Let's see what happens this time. So last time it fell over while it was trying to install cronny for the clients. Yeah, it's probably going to take a while. And there you go. Finally, it's actually finished it. So there's various things that it was going through. I mean, there wasn't really much to do in terms of management access because that had already been set up anyway when we were originally setting this all up. When it came to setting up the clients, it had to make a change to install the cronny package and update the actual config file. But it skipped a task when it came to updating or uploading the server config file because it wasn't really relevant. Likewise, when it came to making actual changes for the actual UFW rules to allow NTP access, well, that wasn't relevant for that particular client computer. So those particular steps were skipped as well. Then we got over to the point of restarting it because obviously the config file had been changed, so it's restarted cronny. Then we get round to the play, which is to configure the actual NTP server. So it has installed the actual cronny package. It skipped the point of uploading the client config because that didn't apply, but it did upload the actual server config, and it's put in our UFW rules because, well, this is an NTP server, and because we changed the config file, it has actually restarted cronny. So aside from those rookie mistakes of forgetting to switch to root for some reason. It's actually worked. Now, just because our Ansible playbook has run, and this time around we didn't actually get any errors, and it looks as though things went to plan, it is still worth checking just to make sure that, well, everything's being configured as we expected. So if we go over to our Debian computer here, which I've got set up as the server, you can see I've checked the actual UFW rules, so we're allowing our management access, we're allowing access to the NTP server as well. And when you check actually cronny here, you can see it's pointing to time.cloudflare.com as expected, and it is actually syncing with that server. One more thing I'm going to check is the actual configuration file for cronny. That's cronny.com. So there's our line, which now shows server, then time.cloudflare.com. Now, obviously in the template, that was a variable. And at the bottom, we've got our two allow lines, so that was all part of a for loop. If we go over to the client computer, check the firewall on that, well, that's allowing management access. And it is actually pointing to our actual internal server. It has actually synced with it, so that's a good sign. We have a look at the config for that one, for cronny to be precise. So that's cronny.conf. Sure enough, where we had a variable in our template, we've now got our IP address. So, as far as I can see, everything has actually gone to plan. Well, hopefully, as you can see, Ansible is extremely useful when it comes to being able to carry out tasks, especially repetitive ones, and when you've got a lot of computers. Sure enough, it does take quite a bit of effort to actually get things up and running and configured to begin with, but once that's all in place, it makes life a whole lot easier when it comes to maintaining and managing your computers. But one final thing I'll do while I wrap up this video is to show you a useful feature to actually do a dry run on your playbook. To do that, basically run the same command as before, so Ansible-playbook, then the name of your playbook, but at the end we put in the parameter --check. And then all what Ansible is going to do is it's going to run through that playbook, but it won't actually make any changes. Now, it's saying up here that there was a change made, but it didn't actually carry out that change, because if I run this again, it's going to come back with exactly the same result. But it's a useful way to actually test out your playbook first, because if we go back to earlier, I ran the playbook and it just fell over. Something went wrong because I didn't swap over to the root account first. That can have consequences when the actual installation or configuration changes aren't fully done. Things can kind of fall apart a bit. So it is useful to be able to do that dry run, find those things out first and fix them before you actually carry out an actual full installation using Ansible. Of course, it's a whole lot better if you've got a lab setup, and that is something to recommend, where you actually test out your playbooks in a lab environment first, and then you port them over to an actual live production environment, knowing that this should already work because your lab and actual production environment should be pretty much identical. Maybe the IP addressing is probably different, but the principle is the same servers that are going to need the same sort of changes. It should go a lot smoother if you do it on a lab first and then do it on the production environment once you know it should go all to plan. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourself that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.